An arbitrary basis spans the space, but it may point in awkward directions with awkward lengths. Very human of it. Gram-Schmidt is the procedure that turns a basis into an orthonormal basis without changing the subspaces built along the way. The entire method is one boring idea repeated with discipline. Remove the components already accounted for. Then normalize what remains. Start with V1. Normalize it to get E1. Then look at V2 and subtract its shadow on E1. What remains? U2 is perpendicular to E1. Normalize U2. And now we have two unit perpendicular vectors. Small miracle. Minimal paperwork. The higher dimensional version only repeats this shadow subtraction against every previous E vector. Now here is the actual algorithm. Assume V1 through Vn is a basis of an inner product space. For the first vector, there is nothing to subtract. Just normalize it, because even V1 deserves basic hygiene. At step K, subtract from Vk all its projections onto the earlier orthonormal vectors. Then normalize the leftover vector Uk. The formula looks like an attack by summation notation, but it only says, subtract every old shadow before keeping the new direction. The key point is that Uk is constructed to be orthogonal to every earlier EI. This is not optimism. It is arithmetic. Take the inner product of Uk with a previous EI. Now expand using linearity in the first slot. Since the previous E vectors are orthonormal, the inner product of Ej and Ei is 0 unless j equals I, and 1 when j equals I. So every old component cancels exactly. The leftover Uk is perpendicular to all earlier E vectors, as requested by the Committee of Common Sense. Normalizing Uk changes its length, not its direction. Orthogonality survives the scaling. Tiny mercy from the universe. Orthogonal vectors are nice, but we also need them to span the same space. Otherwise we just manufactured decorative arrows. At each step, the first k new vectors span exactly the same subspace as the first k old vectors. The formula expresses Uk using Vk and earlier E vectors. Reversing the formula expresses Vk using Uk and earlier E vectors. Also Uk cannot be 0. If it were 0, then Vk would already lie in the span of the earlier V vectors, contradicting that we started with a basis. Therefore the process produces n orthonormal vectors spanning V. That is exactly an orthonormal basis. Mathematics. Briefly acting like it has a plan. Gram-Schmidt is not magic. It is repeated projection removal plus normalization, which is basically cleaning a room, but with better notation. Next time, we will run the algorithm on actual vectors, because sooner or later the symbols demand rent.